Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Minimum number of operations to move all balls to each box. Leetcode 1769. In this problem we are given n boxes represented by binary string boxes of length n, where boxes I is 0 if ith box is empty and 1 if it contains one ball. In one operation we can move one ball from a box to an adjacent box. Box I is adjacent to box J if absolute difference of I and J is equal to 1. Note that after doing so, there may be more than one ball in some boxes. And in the end, we have to return an answer of size n, where ith answer is the minimum number of operations needed to move all the balls to the ith box. Each answer is calculated considering the initial state of the boxes. Then in example 2, at index 0, that is for 0th box, we will move the ball at index 2 in 2 moves, because first we will move the ball here, which will be 1 move, and then we will move the ball here, which will be 2 moves. Similarly, we will move the ball at index 4 in 4 moves, and finally we will move the ball at index 5 in 5 moves, which results in total of 11 moves. Similarly, for box at index 1, we will move the ball at index 2 in 1 move, ball at index 4 in 3 moves, and ball at index 5 in 4 moves, resulting in total 8 moves. Then for box at index 2, this ball is already present, so it takes 0 moves to move it here. Then we move the ball at index 4 in 2 moves and ball at index 5 in 3 moves, resulting in total 5 moves. Then for box at index 3, we will move ball at index 2 in 1 move, ball at index 4 in 1 move, and ball at index 5 in 2 moves, resulting in total of 4 moves. Then for box at index 4, we will move ball at index 2 in 2 moves, ball at index 4 in 0 moves, and ball at index 5 in 1 move, resulting in total of 3 moves. And finally for box at index 5, we will move ball at index 2 in 3 moves, ball at index 4 in 1 move, and ball at index 5 in 0 moves, resulting in total moves as 4. So our answer will be 11, 8, 5, 4, 3, 4. Now in terms of solutions, the naive way will be what we were doing in the example walkthrough. For each box at index I in the string boxes, we calculate its distance to box at index j if that box has a ball. That is, boxes j is equal to 1, and sum up all the distances. However, the time complexity of this approach will be O of n square due to nested loops. And given the constraints of this problem are small, this solution may be accepted as well. Please check out the link in the description below in case you are interested in it. And now the question is, how can we do better? In naive approach, we traverse the whole array for every element again and again. But do we really want to do that? And the answer is no. Let's look at our boxes a bit closely. Suppose for the given array, we have already solved the answer for the ith box. That is, we know the minimum number of operations to move all the balls to box I, and let the answer be x. And now we want to solve for the I plus 1th box. Let's call it y. And now suppose there were L balls to the left of I plus 1th box. That is, there were L balls in the range 0 to I inclusive. Then the total additional operations to move all the balls one step further to reach at I plus 1 will be L. So our answer y will be equal to x plus L. Similarly, suppose there were R balls to the right of ith box, that is in the range I plus 1 to n minus 1. Then the total number of additional operations to move these R balls will be one step less to reach the box I plus 1, and that's why we will subtract R from X. So our I plus 1th answer would be answer of I plus L minus R. So if we know the cumulative number of balls on the left and right side of an index, we can derive the answer for the next or previous index accordingly. But how do we put it in practice? And this is where prefix sum can help us. So as we move from left to right, we can keep a running total of balls encountered so far. That will give us L. Similarly, as we move from right to left, we can keep a running total of balls encountered so far. That will give us R. And now we can use this equation because we have the value for L and R, and now we will start deriving the answer based on it. And when we wrote this equation, we assumed that we already know the answer for ith index, but in reality we still need to compute it. So when we move from left to right and given L balls we have encountered so far, the number of operations at ith position will be total number of operations at the I minus 1th position, that is previous position, plus number of operations required to move these L balls, which will be L itself, because I minus 1 and I are adjacent boxes. Similarly, when we move from right to left, the operation required at ith position will be number of operations required at I plus 1th step plus total number of balls we have seen during this traversal. And sum of the operations from left to right and right to left for each index will be our answer. Now let's see this in action. I am denoting green color for left to right traversal and red color for right to left traversal. Also, as we are computing the values cumulatively, we need only two variables: balls to count the number of balls encountered during both the traversals, whether it being L in case of left to right traversal or R in case of right to left traversal, and ops to keep track of current number of operations that we calculate for ith index. So let's traverse from left to right first. So we start with box number 0 and it does not have any box on left. So number of balls on left are 0 and number of operations will also remain 0. Then we come to index 1 and this time again there is no ball on the left of it. So number of balls stays 0 and number of operations at previous index was 0. So number of operations will stay 0. Then we come to index 2. It does have a ball, but it does not have any balls on the left of it. So number of balls stays 0 and number of operations at previous index was 0. So number of operations stays 0. Then we come at index 3 and now number of balls on the left of it is 1. So number of balls become 1 and number of operations at previous index was 0. But we do have one ball which we have to move. So number of operations now become 1 as well. Now coming at index 4, number of balls on the left are 1 and the number of operations till the previous index was 1. So moving this one ball to the right will cost us one operation. So total operations will become 2. And finally we come to index 5 and it has 2 balls on left of it and number of operations till the previous index were 2 and moving these 2 balls will require 2 additional operations. So total number of operations will become 4. So this was from left to right. Now we have to do the same thing from right to left. So let's again take balls and operations. So for the rightmost box there is no ball right of it. So we will fill in 0 balls and number of operation will also be 0. Then at index 4 we have one ball on the right of it and the box on the right of it does not have any operations, but we need to carry one ball forward. So number of operations for this box will be 0 plus 1, that is 1. Now we come at index 3. Number of balls on the right of it are 2 and number of operation at the previous index was 1. Moving these 2 balls will require 2 additional operations. So number of operations will become 3. Then we come at index 2. Number of balls on the right of it are still 2. But number of operations will become 3 plus 2, that is 5. Because we have to move 2 balls to the left, so that adds 2 operations more. So number of operations now become 5. Then we come to index 1. Now number of balls on the right of it are 3. And number of operations till right previous box are 5 and moving 3 additional balls makes number of operations 8. And finally we come to index 0. Number of balls on the right of 0 are 3 and number of operations till right previous box are 5 and moving 3 additional balls makes number of operations 11. And now our total number of operations will be sum of these two operations and it will be equal to 11, 8, 5, 4, 3, 4, which matches our answer. And although I demonstrated using 2 separate arrays for operations to simplify the explanation, in practice we can use the same answer array to accumulate these operations as we move from left to right and then from right to left, or vice versa. Let's jump into the code to understand it better. First, let's initialize n as length of input string boxes and let's initialize the answer of size n to store the answer for all the boxes. Let's also initialize 2 variables, balls to count cumulative number of balls as we go in respective directions and ops to count the cumulative operations. First, we will go through the boxes from left to right and add current number of operations to our answer and increment number of balls by 1 if current box contains a ball. And for that, we can get the character at ith index and subtract ASCII value 0 from it. And then we update number of operations for next iteration to include the contribution of the current balls. And once we are done with the forward pass, we will reset number of balls and operations to 0 and start the backward fast, that is traverse from right to left. And again add current number of operation to ith answer and increment number of balls by 1 if the box contains the ball, and update the number of operations for next iteration to include the contribution of the current balls. And once we are done with both the pass, we will return our answer, which will contain minimum number of operations for each box. Now let's submit this code. Cool. Now in terms of time complexity, it will be O of n, where n is length of input string boxes, because we traverse a string twice, once for each pass. And in terms of space complexity, it will be O of n for storing the results in the answer array. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.